All right, hi everybody. Here I am back in my kitchen. This is going to be a video covering section 9.8. Hopefully tonight, what is this, April 4th, to 9:30 p.m. I'm going to try to make the section 9.8 video and the section 9.9 video, just so you guys have a heads up. On the last day I gave you a bunch of guided notes. There was a 9.8 day 1 and then a 9.8 day 2. Okay, we have decided you can just take 9.8 day 2 out and just crumple it up and throw it away. Use it as toilet paper if you're running out. 9.9 day 1, we're going to do that one. 9.9 day 2, more TP. You can cross that out. Right. I gave those to you. You already have those. I'm not changing like the material from section 9.8 day 1 or 9.9 day 1. I'm not going to change any of the problems within there. We're just eliminating 9.8 day 2 and 9.9 day 2. Okay. All right. So let's get started here. So this is section 9.8. Oh, I'm going to go now. I don't like seeing my face throughout this whole thing. So see ya. All right. So here's section 9.8, completing the square. Now, when we decided to do, well, not when we decided, when we were forced to do this whole remote learning thing, we, the Algebra 1 teachers, we all kind of got together and we're like, okay, do we really want to do this section 9.8, completing the square? Because that's kind of a really hard topic. But we decided to kind of scale it down a bit. That's why we had you eliminate 9.8 day 2. So we're going to teach you the basics of completing the square so that you guys have a base understanding. So when you go to geometry next year, you're not caught off guard. Okay, so why do we have to do other methods? In this last part of chapter 9, we're talking about different ways that we can solve quadratics. The first way that we learned was by factoring. The second way was by just using square roots if there was no b term, right? Now, this third way that we've got here is completing the square. Okay, complete the square, and you'll understand what I mean. Oh, I forgot an E on complete. You'll know what I mean here when I say complete the square. You'll understand it pretty soon. And then section 9.9, the fourth way is using the quadratic formula. Okay. Now, why do we learn 4 different methods? Well, I'd say the first thing that you should do is if there's no b term, use square roots. Just solve directly. Then if it has a b term, then I would jump up to factoring and say, okay, let's try to factor this because that's the next easiest method. But we know that not all things factor, not all things factor, not all quadratics factor. The methods in previous examples can be used only for expressions that are perfect squares, okay? And not only just for perfect squares, that actually, these methods can only work sometimes. That's basically what I'm getting at here. Okay, these methods can only work sometimes. There are methods where, this completing the square in this quadratic formula will work all the time, regardless of the way that the problem is set up. Completing the square in quadratic formula will work all the time. So some, before where we used to write prime, we're not going to write prime anymore. We're going to figure out a way around that. Okay. So let me start by taking a look at some factorable trinomials here. Like if I had said x squared plus 6x plus 9, and I said, okay, how would you factor that? What would that factor into? You would say, okay, factors of 9 that would add to get to 6 are 3 and 3. So we could say that is x plus 3 times x plus 3. In other words, we can write that as x plus 3 squared, right? 2 things multiplied together, they're the same thing. You can write it as that thing squared. So x plus 3 times x plus 3 is x plus 3 squared. Likewise, if I had x squared plus 8x plus 16, we could say the factors of 16 that add to get to 8 are 4 and 4. So we could say that is x plus 4 times x plus 4, or x plus 4 squared. Same thing here. I don't know why I started a parenthesis there. Get that out of there. If I had x squared plus 10x plus 25. Factors of 25 are 5 and 5. That would add to get to 10. So that would be x plus 5 squared. Let's just do one more for good measure. X squared plus 12x plus 36. Factors of 36 that I had to get to 12 are at 6 and 6. So it'd be x plus 6 times x plus 6, or x plus 6 squared. We can see that these are, pretty easily factorable, right? What's unique about them is that they come out to be the same factor that adds to get to the middle number. So they are actually this thing called what's called a perfect square trinomial, right? And a perfect square, any perfect square, 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are perfect squares, 1, 4, 9, 16, 25, and so on. What that means is that there's a number or just anything that can be multiplied by itself to get that final answer. So this is x plus 5 squared to get this. So that's why we call it a perfect square. Now, these are really nice to use, but the cool part about this method is that we can force this into happening, okay? We can force a trinomial into being a perfect square. And when we do that, it actually sets up pretty nicely when we go to solve it. All right, so let me teach you the process. Okay, now, I should have, before scrolling down, we could take a look and see what's the relationship between this and this, that number down here and that number up there, 3 to 6. Well, that was double. What's the relationship here? 4 to 8. Same relationship? Yep. Same relationship? Yes. Same relationship? Yes. So what we're looking for here is if I'm trying to figure out what completes the square, what forces this to happen, what I'm going to look for is a number that divides this b term, this second term, in half. What divides 10 in half? 5. What's divide 12 in half? 6. Okay. So this is the method of completing the square. We're going to find that we're not going to really use a c term here. It's going to be x squared plus bx. I'll tell you what happens to that c term soon. But how do we figure out what this turns into? Well, this number, this b term here, the relationship between that number and then the number that goes in the parentheses is b over 2. Okay, this actually turns into b over 2, whatever that is. Okay, now, so what goes like in this box, right? What goes at the end here? What makes this a perfect square? Well, you take this number divided by 2. 6 divided by 2 is 3. You square it, you get 9. So this should be x squared plus 6x plus 9 to make that a perfect square. Okay, so what we do here is that we add, the process is adding b over 2 squared, whatever half of b is, squared. Okay, so let's practice this a little bit. All right, complete the square for the expression. So we're going to this direction just basically says fill in the blank, and then write the resulting expression as a binomial squared. Binomial meaning 2 terms squared. All right, so taking a look here, what's my b term? My b term is 20. So b divided by 2 is, 20 divided by 2 is 10. Well, what goes in here? 10 squared. Okay, another way to write that is 100. Kind of psyched you out there. I wrote it and then I erased it. Okay. Now, why did I write that? Well, because remember that the relationship between this number and the one that goes here is that 1 to 2 relationship. That's just cut in half. So that's just x plus 10 squared. Okay. So my b over 2 is 10. That's the number that goes right there. Okay. All right, let's try another one of those. Okay, watch out for the negative sign now. The b value is a negative 14. So if I'm like jumping ahead straight to this, what's b over 2 then? Well, what is negative 14 over 2? Negative 7. So this actually turns into, please don't say plus a negative 7. This is just minus 7. So what number would fill in this blank? Well, it would be negative 7 squared would be 49. Positive 49, right? Negative times a negative is a positive 49. So that's what fills in my blank. Okay, let's do this process one more time. Again, this is just getting you prepared for how to solve using this. This isn't actually any sort of solution or anything yet. Okay, so what's b here? b is 2. So b over 2 is 1. So I can go to my binomial and say positive 1. squared. So what fills in this blank here? Well, that's b over 2 squared. Well, once 1 squared is just 1. Check it to make sure. Factors of 1 that add to get to 2, 1 and 1. Yeah, that does factor out correctly. All right, so now that we understand the process of completing the square, let's figure out how we solve using completing the square. Now, this chart that I have down here and that you see in your guided notes, we're going to have to edit that a little bit. That was if we were going to teach the whole full-blown completing the square both days. We're not, paring it down a little bit, so I'll kind of talk about it. Now, we can complete the square to solve any quadratic equation. Any quadratic equation, any, okay? Whether it's factorable or not. Now, here's how we do it. So remember that to complete the square, we just had x squared plus bx. So where did our c term go? Well, the c term went over to the other side. Okay, so this is not in standard form. The c term got moved over to the other side. Okay, so what are my steps? First step, collect variable terms to one side and the constant to the other. C term goes on the other side. Second step, and now this is what we're editing out. We are not going to have to do step 2. Okay, so you can kind of cross that out. Okay, we do not need to do step 2. That's if we were going to do the, the full-blown whole section 9.8, but we're not going to. Now, complete the square by adding b over 2 squared to both sides of the equation. Please underline that word both, because whatever we do to the left side of the equation, we must do to the right side of the equation. So if I need to actually force it into being a perfect square on the left side, whatever forced it into being a perfect square needs to be done to the other side as well. Next, we factor. We turn it into that binomial squared. Factor the left side. Step 5. Then we actually just take the square root of both sides. And we solve for the values of the variable. Okay, so let's try it out. All right, here we go. So first step, collect all the variable terms to one side, check. Constant to the other, check. All right, so now I have to, what I like to do here in this case is I like to space it out. I like to leave room. Because I'm thinking, what fills in my blank? Just like the problems that we were doing here. What fills in this blank? Well, what's half of 16? My b value is 16. What's half of 16? 8. Okay, so, and what's 8 squared? Well, that's b over 2 is 64, right? So what fills in my blank is a 64. Now remember, whatever we did, we just added this 64 to the left side. I can't make this equation unbalanced. Whatever I do to the left side, I must do to the right side as well. All right, now x squared plus 16x plus 64. We turn that into x plus 8 squared. How did I know that it was going to be 8? Remember, this is always just b over 2. That should match here. Always, 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 always. Now, what is this? Negative 15 and 64. Okay. So 64 minus 15 gets us 49. How nice. Why do I say that that's nice? Because, well, how do I get this square root to go away? I take the square root of the opposite side. We learned that last section, right? So it's x plus 8 is equal to plus or minus the square root of 49. So x plus 8 is equal to plus or minus 7. Now, how do we deal with this plus or minus at this point? Well, we create two mini equations. X plus 8 is equal to positive 7. X plus 8 is equal to negative 7, because that's what that plus or minus sign really means, right? And don't forget, when I take the square root, we must write this plus or minus. So I do one positive version of that 7 and one negative version of that 7. I subtract 8 to both sides, all parts. This gives me x equals negative 1. This one gives me x equals negative 15. So my solutions here were negative 1 and negative 15. Okay, that is called completing the square. Okay, so from here on out, all we're doing is just examples. I suggest you try to pause, try the problem, and then play when ready. Okay. All right, so step 1 is done for us again. The variable terms are collected to one side. The constant is to the other. I have to leave a little bit of room so that I can complete the square, so that I can force this into being a perfect square. Remember, whatever I add here, I'm going to also have to add here. Ooh, excuse me. All right. Don't worry, I'm not sick. All right. So my b value is 10. Oops. My b value is 10. So b over 2 is 5. Okay, so that means b over 2 squared is 25. So this is a 25 that gets added to both sides. Now, this factors into that x plus 5 squared. Negative 9 plus 25 is 16. I square root the opposite side. I get x plus 5 is equal to plus or minus square root of 16 is 4. At this point, I break it up into my two little equations. X plus 5 is equal to positive 4. X plus 5 is equal to negative 4. Subtract the 5 over to the other side. X equals negative 1. Subtract the 5 here. X equals negative 9. So those are my two solutions. Okay. Let's keep it going. All right, watch out for the negative here. So I leave room. Again, step 1 is already done. Leave a little bit of room. I say whatever I add here, I have to also add here. So what's my b value? My b value is negative 12. So b divided by 2 is negative 6, right? So I can, you know what's interesting about this is that I can go right away to say x minus 6 right here, to that last step. Now you may be thinking, well, then why do I even need to write this whole blank right here? Well, because don't forget, you have to square this. And whatever I do to one side, I have to figure out what that is so that I can do it to the other side. Negative 6 squared is a positive 36. Negative 20 plus 36 is 16. I square root the opposite side. Square root of 16 is plus or minus 4. Too many equations. X minus 6 is equal to positive 4. X minus 6 is equal to negative 4. I add the 6 to both sides here, and I get x equals 10. I add the 6 here to both sides, and I get x is equal to 2. So my solutions are 10 and 2. Okay, take a look here. Next problem. You're going to notice that we're going to do a lot of repetition here. Repetition is key when learning both completing the square and using the quadratic formula, which we'll learn next in section 9.9. So I've got x squared minus 4x. I'm going to add something here and something here. What is that something? Well, b is negative 4. So b over 2 is negative 2. And when I square it, I get positive 4. So positive 4 gets added to both sides. So that would be an x minus 2 squared is equal to 81. I square root the 81. I get x minus 2 is equal to plus or minus 9. X minus 2 is equal to positive 9. X minus 2 is equal to negative 9. Oops. There we go. Add the 2 to both sides. I get x equals 11. Add the 2 to both sides. I get x equals negative 7. Okay? Okay, take a look here. Again, step 1 is already done for us. I get x squared minus 6x plus something. B is negative 6, so b over 2 is negative 3. And when I square it, I get 9. All right, so that gives me a 9 here and a 9 here. So that gives me an x minus 3 squared is equal to 1. Right? And how do I know that this is negative 3 again? We're just going to go over that one more time. Two ways. If I can actually just factor it. Factors of 9 that add to get to negative 6 are negative 3 and negative 3. But it's also right here. B over 2 is always the number that goes in the parentheses there. I square root the opposite side. I get x minus 3 is equal to plus or minus 1. So here comes my two equations, positive 1 and negative 1. Add the 3 to both sides. I get x equals 4 and x equals negative 1 plus 3 is 2. X equals 2. X equals 4. Last problem up. Okay, I get x squared plus 8x plus something is equal to 9 plus that same something. My b value is 8, so b over 2 would be 4. So when I square it, 12 power, that would give me 16. So I put 16 here, and I put 16 here. I get x plus 4 squared is equal to 25. Square root the opposite side, I get x plus 4 is equal to plus or minus the square root of 25 is 5. So x plus 4 equals 5. X plus 4 equals negative 5. I subtract the 4 here, I get x equals 1. I subtract the 4 here, I get x equals negative 9. And those are my two solutions. Okay. All right. I hope we're all having a good day, and I'll see you later.